So this video PowerPoint is about writing algebraic expressions. So it takes what we know about literacy in the language of maths and works with us to convert those into mathematical number sentences or equations. So that's our learning goal, being able to convert between equations and their worded problems. So before we begin, there's certain things that we need to understand, and that is the language of maths itself. So we have our four basic operations here: addition, subtraction, multiplication, and division. Each of those have certain synonyms or words that mean the same thing. So for addition, we have sum, plus, add, more than, increase, combine. The ones in red are the ones that are more commonly used. Subtraction, keywords there, there's a heap of them, but difference and less than tend to be seen more often than the others. Multiplication, product is usually the one that we use most often there, or many times more, times greater, words like that. Division, the word we're looking there that often gets confused, is quotient. So that language is important, and when we're looking at these problems, what we're trying to do is identify those words. So here's some examples for us to look at. We've got four different questions there, and we're going to look at them one at a time. So here's the first one. As always, the first thing we do is underline or highlight keywords. So we're looking for things here that will help us. So the first thing you're going to notice is more than. So that's our keyword, and that is what we're looking for. Now when we write these, we always start by stating what our variable is. So our starting point or our ending point. So Ben's age is what we're looking at. That's our initial comparison. So we're going to let B equal Ben's age. You could use A or X, it doesn't matter. But we always do that first step. It's part of our communication and lets us know what's going on. So 6 more than means plus. So we start with Ben's age and we add 6. So B plus 6. Here's the next one. Take a moment to think about what that might be. So the key word is what we're looking for, and that's product. Product of A and W. There are two variables or pronumerals. A times W is the answer. So when multiplying, you don't need to include the multiply sign, so we can just write AW. And we understand that means multiply. Question 3. One more than the age difference between Albert and his son, Walter. So highlight or underline keywords first. Take a moment and see what you think. Feel free to pause the video. Keyword, one more than, the age difference. So there's actually two steps to this expression. So let's start with our variables. We have Albert's age and we have Walter's age. So A and W are our two variables. So one more than the age difference. So let's start with the difference. A take W. And we'll put Albert first because Albert is the older one. This makes things work a bit easier for us. So what's the difference? A take W, and then we plus 1. The last example is this one. 5 times an unknown quantity is added to 6 times another unknown quantity. So let's have a look at that. 5 times, that's multiply. Added is addition. 6 times. We notice we have two unknown quantities. So there are two variables. That's our first step. Let x be the first quantity, y be the second quantity. So we have 5 times one unknown, so that's 5x. 6 times another unknown, that's 6y. And we add them together, so it's 5x plus 6y. Alright, so these are a little bit more complex. Let's have a look at how these ones work. Once again, highlight your keywords. So these are worded problems that are leading us into where we start solving real life equations. Now, a lot of the examples we're looking at here seem fairly simplistic, and we probably tend to work them out without any formal algebra involved. But it's about understanding the process and building that to more complex situations. So the keywords here, what are we looking for first? How long would it take to iron all of Alan's shirts? So that's where I would start. How long? All shirts. Now we can look at the rest of the information. It takes 8 minutes for a single shirt. So there's the keywords. Let's have a look. 8 minutes, single shirt. So we're going to start with what we don't know, how many shirts we have. So that's our variable. Let A be the number of Alan's shirts. You could have used S or any other letter. And every shirt takes 8 minutes. So logically, 8 multiplied by the number of shirts gives the amount of time it takes. So the answer is 8A. Alright, let's go through this one. Using our see, plan, do, check method, let's see what we know. Brenda has 5 more than Camillo. 5 more than means addition. What are we after? How much money does Brenda have? Now, I've highlighted most of the words there, but that's because it's a simple problem as far as the words. Let's have a look. Key bit there is 5 more than. So let's take the two variables. We don't know how much Camilla has. We don't know how much Brenda's got. Brenda we'll call B. C we'll call Camillo. And we know that Brenda has Camillo's amount plus 5 more. So C plus 5. Okay, bit of an Aussie rules sports idea. Let's highlight using our C. So our C says 3 more goals than behinds. And what we're after, how many points? So for those of you who are not entirely familiar with Aussie rules, a goal is 6 points. A behind is 1 point. Okay, let's have a look now. So that's our C. Our plan, we're going to put them together into some sort of algebraic expression using some of these keywords, more than. Okay, here we go. Keywords, as we identified. So we're going to start with let G be the number of goals kicked. So the points from the goals kicked was 6 times G. And in this case, we're actually building it up one step at a time. We're not trying to do it all at once. Now, the number of behinds he kicked, the number of goals, take 3. Okay, so that means that's the number of points also, because every behind he kicked is worth 1 point. So the total points is the number of goals plus the number of behinds. 6G plus G minus 3. And we can group and simplify those like terms. So there's actually 7 G's here. Take another 3. That's something we'll be looking at shortly, is how to simplify those expressions if you've forgotten from last year. So that's the end of that lesson. It's all about working between those worded problems and their equations by identifying common terms.